Welcome back. Today we are going to talk about systems, but not systems of equations. We're going to talk about systems of inequalities. So here I've been given two inequalities. X plus y is less than or equal to 4, and x minus y is greater than 2. And I want to identify the solution set for the system of inequalities. So instead of these being equal signs and graphing lines and finding the intersection of the line, we're going to look at the way that, if you recall, graphing inequalities resulted in shading of particular regions. So what we are going to be interested in is regions where the shading has been overlapped. Okay, the first thing you want to do is actually graph these. So remember, the first thing to do is graph the boundary line. So they're in standard form. So for the first one, what I'll do is I'll just get the x-intercept and the y-intercept. So here the x-intercept is 4, and the y-intercept of the boundary line is also 4. So let me go ahead and plot these points right here, 4 and 4. Now, since it's less than or equal to, so let me actually solve. Actually, let's put all right, first of all, let's graph the boundary line. Okay, the boundary line is going to be solid because it has an equal to symbol. Okay, so I'm going to have this solid line from these 2 points right here. We make it as long as I can, going through these 2 points. Okay, and arrowheads. So here's the 2 points. Now the shading, to figure out the shading, let's put the origin in. Okay, the origin is the coordinate 0, 0. Is it true that 0 plus 0 is less than or equal to 4? That is true because 0 is less than or equal to 4. So in that case, the shading is going to be below like this because the point 0, 0 made the inequality true. Okay. For the next inequality, the x-intercept is 2. Let's plot that right there. And the y-intercept, if I took the x away, I'd have this situation here, which means that if I divide by -1 on both sides, right here, we'd have, actually, you know what, we're supposed to be thinking of this as an equal to symbol. So what we're doing, we're graphing this as a boundary line. Okay, so we have an x-intercept of 2, and we have a y-intercept of -2 for our boundary line. This is not the inequality. This just helps us figure out the line that begins the shaded region. Now it's going to be shaded because the boundary line is it's just strictly greater than, it's not less than, or it's not equal to rather. Okay, so here's my boundary line. Now let me think about the shading. The origin is up here, so let me see if the origin is actually shaded. So again, let's put in 0, 0. 0 minus 0, is that less than 2? No, is that greater than 2 rather? So 0 is not greater than 2, that's not true. So we're actually going to shade this line in an area that does not include 0, 0. So don't get confused with the other line that we just shaded. Okay. We're shading below the boundary line, the dashed boundary line, so that we don't include the point 0, 0 because it did not make the inequality true. Okay, so here we have graphed the two inequalities. Now, let's consider a few of these points. Okay, so let's first of all consider a point that's just in the blue region, blue shaded region, and not in the purple shaded region. So let's consider this point here, -2, 2. Does it satisfy the first equation? Well, is it true that -2 plus 2 is less than or equal to 4? Yes, that is true because 0 is less than 4. So it does satisfy this one. Does it satisfy this one? Is -2 minus 2 greater than 2? No, it doesn't because this is not true. Okay, so no, this is not satisfied. So I guess I should put, yes, a y and an n. How about that? A y and an n. So something in the blue region satisfies one but not the other. So let's consider something that's just in the purple region and not in the blue region. So that would be 6, 2. Okay, so if it's in the purple region, it is not true that 8 is less than or equal to 4. So no is the answer here. Okay, 6 minus 2 is 4, and that is greater than or equal to 2. So yes, that is true. Now, so I should actually have a column here to say, is it a solution to the system? So I'm wondering, is it a solution to the system? Well, if it's a solution to one but not the other, then the answer is no, it's not a solution to the system of inequalities, given the system together, right? So a system of equations was all the points, or the single point that satisfied both equations. Solving a system of inequalities is all the shaded points that satisfy both of the inequalities. So since it satisfied one and not the other, in both cases, both of these points are not a solution to the system. Okay, now let's consider a point that's in both of the shaded regions here. So this point is 1, 2, 3, -1. So it's 3, -1. Okay, is it true that 3 plus -1 is less than 4? That is true because that's 2. So yes, it satisfies this one. 3 minus a -1 would be 4, and that is greater than or equal to 2. So yes, that satisfies this one. And so the answer is yes, that satisfies the system. So everything that's in the doubly shaded region, the overlap of the shaded regions, is going to be the solution set. Now this is something you absolutely need to remember. When you have to identify the solution set, what you need to do is draw a nice capital S in this. This tells everybody that you know that the solution set to this inequality is the area where there's overlap in shading. Okay? Now, one particular thing that needs to be addressed here is the points along the boundary lines. Now remember, these points along this boundary line is part of the solution set. So I'm going to actually highlight the solution set. So these points are part of the solution set. Everything that's here is the solution set. But what's really, really important to understand is none of the points on this shaded region are part of the solution set, right? Or the not the shaded region, the dashed line right here. None of these points are part of the solution set to the system of equations because it's not part of the solution set to one of the equations, okay? And this point right here is not part of the solution set to the system because, again, it's the intersection of a solid line and a dashed line. That is never a solution to the system. If it were the intersection of two solid lines, then it would be a solution. If it were the intersection of two dashed lines, then it would not be a solution. But it is the intersection of a solid and a dashed line. So again, it's this point right here is a solution to one system of inequality, or one inequality, but it's not a solution to the other. So it's not a solution to the system. Let's try another one here. Okay, we have x minus y is greater than or equal to -1. So our x-intercept is x is equal to -1, so that's right here. And our y-intercept is y is equal to 1. Y is equal to 1 right here. So there's our boundary line. Now it's going to be a solid boundary line because we have an equal to symbol there. So I'm going to just go like this and put my arrowhead on both ends, nice and big. Now let's think about the shading. So the origin's here, let's put the origin in. 0 minus 0, is that greater than or equal to -1? 0 is greater than or equal to -1, so we are shading below like this. Okay, now y is greater than 2. Now this is funny because it would seem like it was a one-dimensional inequality, but I want you to remember that the boundary line is going to be y is equal to 2. So that right there is a horizontal line segment like this. Now since it is it's just greater than, it's not equal to, it's actually going to be a dashed line like that. Okay. Oh. So it's going to be a dashed line, and actually I moved it, there we go. The line should be moved. So it's downward. Okay, so it's going to be a dashed line and we're going to shade above it. So we want all the y values above this area. Okay, so the only part of the solution set is actually this little region right here. This is the solution set, and if I were to highlight it, I can go ahead and show you right here. Oh, that indicated not the solution set before, so here, let me put it in yellow. So these are all members of the solution set, including the solid line, but not including the dashed line, and not including the point right here. This little point right here, which is the point 1, 2, is not a member of the solution set to the inequality because it satisfies 1. It is true that 1 minus 2 is greater than or equal to -1, but it's not true that the y value is greater than 2. So it satisfies one inequality but not the other, so it can't be a solution. can't be part of the solution set to the system. Okay, let's try one more. So here we have an x-intercept of -1 and a y-intercept of 1. Looks like the same one that we just had right here. Whoops. Oh, it actually will be a dashed line, good, because it's a strict inequality. Okay, and we are going to shade. Let's try to think about how we're going to shade here. 0 minus 0 is less than -1. It is true. No, actually, this is not true. 0 is greater than -1, so it's not true that this is not true. We are not going to include 0, 0. So let's shade upward here. Then we have a system where the x-intercept is 3, so 3 right here, and the y-intercept is -3, so we have -3 right here, and it's a solid line. So here's our line right here. And let's try the origin. Is it true that 0 is greater than or equal to 3? No, this is not true. So we're actually shading this below. So this is a particular case where there is actually going to be, since these are, the boundaries are not going to be, and actually they have the same slope. So here, these lines are parallel, and they don't really look entirely parallel. I think the line is a little bit off here. So these lines are actually parallel, and there's no region in which they're overlapping. So there's no solution to the system of inequalities. No solution to the system. Okay, because each inequality has solution sets to them, but there's no overlapping region there's no overlapping shaded region. Okay, finally we have a word problem. So let's say that Rosa is buying 2 t-shirts and shorts. She spends, so let's let X be t-shirts, and we'll let Y be shorts. Okay, the t-shirts cost 12 and the shorts cost 20, and she wants to spend no more than 120, and she needs to buy at least 4 items. So that means that 12X plus 20Y has to be less than or equal to 120, right? And we know that X plus Y has to be greater than or equal to 4. So the items together have to be greater than or equal to 4, and the cost has to be less than what she wants to spend. Okay, so just quickly graphing this, the x-intercept here is 10, and the y-intercept here is 6. Right? So the boundary line goes between these two, and it is a solid line. Actually, it will just stay in quadrant 1, so I don't need arrowheads. Now here the x and y intercepts are both 4, so let's go ahead and plot those. 4 and 4. Oh, you know what? I actually didn't get the first, the shading first. So for here, x plus y, if I put 0 and 0 in here, I would include the origin because 0 is less than or equal to 120. So this inequality is going to be shaded below. Now, for the next inequality, let's see, it's again going to be a solid line between them. Okay, and for this inequality, it's not true that 0, if I put x and y in as 0 to indicate the origin, it is not true that 0 is greater than or equal to 4. So I'm actually shading this inequality above. So actually, technically, it would be this entire region up here. That's where this one would be shaded. Okay, and actually, if I just, whoops. Sometimes what people do is they shade with a crosshatch. So I should have done that. So here I could have shaded in the opposite direction. And you actually just need to shade this whole thing up here because that is also in the, it's for the bottom inequality. It's all these values where x plus y is greater than or equal to 4. Well, the solution set in this situation is here, right? It's the in between the two lines there. Okay, so if I were to highlight it, which I'm going to do now, it would be everything in between here and everything along the boundary lines because they're both they are both solid. Okay, if I were to pick out some pairs just to make sure and check. Well, let's see, I could have the pair of this pair would work, right? 3, 1. So it's true that 3 plus 1 is greater than or equal to 4. It's also true that, let's see, 3, 1, that 36 plus 20 is less than or equal to 120. So that point works in terms of the parameters that we had given here. A point like this would work, 5, 2. So 5, comma 2. It is true that these two values added together are greater than 4. It's also true that 60 plus 40 is 100, so it's less than or equal to 120. So every value here works. I'm trying to get a value that's right on this boundary line. So 2 and 5 also works, right? 2 plus 5 is 7, which is greater than or equal to 4. And 24 plus 100. Ooh, actually that doesn't work, right? Let's see. 2, 5. This would be 24, and that would be 100. And 24 plus 100 is actually is greater than 120. So that point would not work. It's hard to tell from this line. So it doesn't actually, that line must not go through that point. That point must be just a little bit above that line. Okay, but you can see that you can pick any of these integer values that meet on the coordinates. It has to be integer because we're talking about whole t-shirts and whole shorts. But that's how you solve the system of inequalities. You create the system, you graph them, and then you shade their region. And oftentimes a follow-up question is pick a few values for the system and make sure that they work for the system, right? So that's the end of the lesson for today.